Hi everybody, and welcome back to another episode of Cellular and Wireless Unmasked. Today we're going to be talking about 5G, what it means, the differences in 5G, because yes, there are a couple of differences. But before we get to 5G, I wanted to give a shout out to our sponsor today, Meta Design and Manufacturing. They're here in Vallejo, and here's a little bit about what Meta does. Meta Designs and Manufacturing is located here on Mare Island in Vallejo, California. They specialize in computer-aided design and manufacturing utilizing different types of materials like metals, wood, and ABS plastic. If you can think of it, Meta can help you design it and build it for you right here in the USA. They specialize in solutions for utility, telecom, architectural, and home furnishings. Contact Meta today for a complimentary quote, and they'll help you with your project. Thanks. So that's a little bit about Meta and what they do here in Vallejo. Let's jump into it. So today, the goals with 5G, I'm not going to explain the details and get technical with this, but I wanted to give you an overview of the different types of 5G and what it means when your phone has that little 5G icon lit up. So looking at it from a macro level, 5G is divided into two types. You have your level 1 5G, which is everything below 6 gigahertz. And you have your level 2 5G, which is everything above 6 gigahertz. That's your millimeter wave stuff, and we'll get into that here in just a minute. But I wanted to focus on what the level 1 5G looks like, how you identify it, and is it really a big deal? Okay, so level 1 5G, or the 5G services below 6 gigahertz. For the 5G services we're seeing today that started to roll out about 2 years ago, the 6 gig and below stuff is basically, it's reallocation of existing bands. So in previous videos, we talked about 600 megahertz, 700, 850, 1900, and 2100. So we talked about these bands and how they're used with 4G. And really with the 5G L1 stuff, the stuff below 6 gigahertz, it's really a repurposing of this. And in this mix, I want to include the 2500 that T-Mobile recently picked up from Sprint. That's a big part of today's L1 5G. So when you're running around town and you look at your phone and you see that 5G icon lit up, depending on your carrier, you might have really great download, really good data speeds, or you might have just so-so, and you might look at your phone and go, what does all this mean? What it means is the level 1 stuff is your long-range 5G. It fills in the gaps between the level 2 stuff, and really it's a small step above what we have today in 4G. The level 1 stuff is still considered 5G because it's still 5G NR. It's a new radio. 5G NR, new radio, which means at the macro sites, at the small cell nodes, at the DAS nodes, you have a new radio, and it looks like this. So really what you see with the level 1 5G is repurposing of the existing cellular bands that we use today. In some cases, they'll do the carrier aggregation, they'll make it into a larger channel. There's some expanded 2100 bands they use. The CBRS band of 3.5, that's kind of a private LTE. You've got a lot of different options in the L1 band, the L1 type of 5G, using the existing frequency bands. Now T-Mobile, right now, they have a lot of frequencies, I can't read that, in the 2500 band. Okay, 2.5 gig, 2.6 gigahertz. They have a lot of bandwidth. The channels are huge. So right now in this level 1 5G game, T-Mobile's crushing it. Their data speeds are good. They've got a lot of capacity with that frequency band. And as we know, the higher you go in frequency, the better your data speeds. So the more those frequencies are shrunken into smaller frequencies in the higher frequency range, you get more data through in each channel. So the 2500 is great for that, and they have a lot of bandwidth. So right now, T-Mobile for L1 5G is killing it. So when you see T-Mobile 5G, you're generally going to have really, really good speeds. But the rest of the 5G that you see with the other carriers, I don't want to harp on them, but their level 1 5G isn't that impressive, and you probably noticed that. Now what's really impressive and what's really been hyped up is the level 2 stuff. The millimeter wave 5G. Let's talk about that. Okay, I hope you can hear me. Meta's doing some manufacturing right now. But let's talk about the level 2, the above 6 gigahertz, or what's commonly known as millimeter wave 5G. When the hype for 5G came out, and everybody was, oh, we've got 1, 2, 3, 4G, we know what all those do. What does 5G do? And all these capabilities and promises came out about low latency and 1,000 megabits per second download speeds were hyped, that gigabit per second. That's all millimeter wave. What does millimeter wave mean? If you look at the wavelengths of different frequencies throughout the cellular band, the wavelength for the lower frequency stuff, which is your long range, your long reach cellular bands, these wavelengths can be quite big, couple of feet. 850, it's about 1 foot per wavelength. Millimeter wave means you're going from this kind of a wavelength to really, really tiny stuff. And the millimeter wave stuff is your frequencies in the 25 to 40 gigahertz. I mean, we're talking really high frequency stuff. Now, the lower frequency bands here that propagate well, that go through walls and windows really well, are great for L1 5G. But they don't work so well for millimeter wave because they're just too low, too big. So millimeter wave is 29 gigahertz, 39 gigahertz, super high frequency, super giant bandwidth. So I was in a discussion with somebody about what does it mean to go from 4G to 5G. And somebody said, well, it's like going from a 2-lane highway to a 5-lane highway. But really, it's an order of magnitude 10 times that, 100 times that, going from a 2-lane highway to a 200-lane, 2,000-lane highway. It really is mind-boggling when you look at the capabilities of the bandwidth of a millimeter wave signal because the channels are so huge. This is relatively unused spectrum, so the cellular operators took that and said, let's take those large chunks of spectrum in the millimeter wave band and let's use those for our 5G services. And these are the impressive 5G, the level 2 stuff. You'll notice it on poles because you cannot separate the antenna from the radio with coaxial cables like you do with 4G. The radios that are typically used for millimeter wave are active antennas. So you have your radio and your antenna is basically the forward section of that radio. So it's all one unit. You've got very, very tiny sections of coax that connect the antenna to the radio. And you do that because at these high frequencies, these 29 to 39 gigahertz frequencies, the attenuation, the loss of signal in the coax is so high that you don't want to have that separation of the radio from the antenna. You can do that sub 6 gig. You have loss, but it's not very high. It's negligible. But in the millimeter wave, that L2 above 6 gig, that loss is huge and it hurts your signal. So what they do is they combine the radio and the antenna into one unit. And you'll notice it looks like this. So those are some of the examples of the L2 millimeter wave sites. What you'll see on a lot of small cells and the millimeter wave deployments are small cells. Why? The millimeter wave high frequency, 29 to 39 gigahertz, 25 to 40 gigahertz, this range, they don't propagate very well. You can't have that mountaintop macro site because the millimeter wave attenuation in free space is so high it won't reach the end user. So the vast majority of your millimeter wave sites are going to be small cells. the light poles, the wooden poles that are right in focused areas like downtowns, around airports, and places where people congregate. So what you'll see on your average pole is you might see an antenna on the top, down to your pole base. Somewhere in the middle of the pole, what you're going to have here is your 4G radios. So you're still going to have 4G in a lot of these poles, and you're going to have your 4G antenna at the top, like we talked about. This is 4G LTE. 4G LTE. Your radios are here, and the top of the pole has your antenna radome. And you're going to have coaxial cables that join the radios to the antenna. Now, with the millimeter wave, you can't, because the attenuation, the signal loss in that cable is going to be too high. So what they do is they have the radios right here, below the 4G. This is your 5G level 2 millimeter wave active antenna. So like we showed before, the antenna and the radio are one unit. So at your 4G radios down here, typically it's a couple different radios. They do a couple different frequency bands for 4G LTE. They connect those with power and fiber optics. The fiber optics carries that data back to the central network to connect to other services. With 5G, you still have that power, you still have a fiber link, there's just no coax. Not really. There's tiny sections of coax that connect the antenna to the radio itself. So it's basically one unit. They call that an active antenna. The radios have the antenna basically affixed to the front with tiny pieces of coax. 4G LTE, you can separate your antenna from your radios. 5G, millimeter wave, it's all one. It's an active antenna. One of the other reasons why the antenna and the radio are one unit for your L2 millimeter wave 5G is they use a technology called massive MIMO. MIMO, in simplest terms, just means multiple in, multiple out. Anytime you have more than one antenna element, that would be SISO if it were one antenna element, single in, single out. That's not uncommon to have SISO. You don't get as good throughput with SISO as you do with MIMO. But MIMO in 4G systems is 2x2 MIMO, 4x4 MIMO. That's pretty much it. It's basically multiple antenna elements inside the 4G antenna radome. What 5G uses is something called massive MIMO. So in 4G, you'll have 2x2 MIMO or 4x4 MIMO. In some of the 5G active antennas, you'll have 128 by 128 MIMO, which means you have 128 different antenna elements and different antenna pathways. So when you think about it, if your phone can take advantage of that massive MIMO, instead of having 2 or 4 pathways, 2 or 4 channels between the small cell or the macro cell and your phone, you have 128 separate pathways for that data. And that's why the level 2 millimeter wave 5G is so impressive. That's how you get to that 1 gig, 2 gig, sometimes 3 gig from these sites. They're really impressive. The high frequency band combined with the giant bandwidth in the channels and the massive MIMO, that's what makes that 5G so impressive in the LT form, or the L2, level 2 form. So what I want you to take away from this video is 5G comes in 2 flavors, level 1, level 2. Level 1 is basically repurposing some of the existing cellular frequencies to use for 5G. In the case of T-Mobile and their 2500, that 2.5, 2.6 gig band, they're doing great. They have a lot of frequency there. So kudos to T-Mobile for their L1. They don't have a lot of millimeter wave right now. Verizon and AT&T are aggressively building out millimeter wave in most downtown areas where people congregate. But in the future, when we see more of this millimeter wave stuff, that's when you're really going to see new capabilities grow with 5G, taking advantage of the massive MIMO capabilities of these active antennas. And that's really going to cause that next step. Are we there yet? Not really. You're going to see a lot of that 5G. Most of it's going to be L1. If you want to check which 5G you're looking at on your phone, pull up a speed test and run a speed test. See what you got. If it's millimeter wave, you're going to see impressive speeds. If it's L1, it might be impressive, it might not. This is very hit and miss. These channels are very crowded, and these are not. Not many phones have that millimeter wave capability. So you've got a big bandwidth, not a lot of users, massive MIMO, huge channel width, and big power coming from these. All right, in short, I want to thank you for watching my video today on 5G, what it means, the differences between the L1 5G, the L2 5G, the millimeter wave stuff. This is the impressive 5G. This is still 5G, still can be impressive, but this is what you see in most places. This is your long range, low frequency 5G, your L1, your L2 stuff, the millimeter wave, that's the impressive 5G. I showed you what some of those examples look like on the small cell sites. That's where you're going to see the vast majority of your millimeter wave. I want to thank Meta Design and Manufacturing here in Vallejo for hosting our video today. I'll put a link to their website down in the comments. And as always, I'd love to have you subscribe to my channel for future videos. Any questions or comments, leave them right below in the section where you leave comments. I'll do my best to answer them. I'll look forward to future videos with you soon. Thank you so much.